So get this right. The other day, I'm trying to make my grandma's famous cookies. Decided to double the batch. Flour everywhere, it was a mess. Turns out, needed twice as much butter too. Duh, right. That's when it hit me. Proportions, they're sneaky little things. And that's what we're diving into today with you, the fascinating world of direct and inverse proportions. We're cracking open a mathematics textbook for this one, but trust me, this is going to be way more interesting than cramming for a math test.
Way more interesting.
We'll uncover how these mathematical concepts pop up everywhere.
Yeah.
From adjusting recipes, which clearly I need a refresher on, to understanding the logic behind maps.
And so much more, yeah.
Get ready to unpack two key types of proportions, direct and inverse. So first up, let's break down direct proportion. Imagine, you're at the grocery store, and you see that 1 kilogram of sugar costs $2. Now you're baking a cake, ambitious cake.
Big cake.
Need 3 kilos. Naturally, the more sugar you buy, the higher the cost, right?
Right.
That's direct proportion in action.
Exactly, yeah. What's fascinating about direct proportion is that as one quantity increases, the other increases at a constant ratio. So if 1 kilo sugar is $2, then 3 kilos will be $6. The ratio stays the same.
Okay, makes sense. It's like when I fill up my car with gas. The further I want to drive, the more fuel I need.
That's a great example. Let's say your car uses 4 liters of fuel to travel 60 kilometers. If you want to travel twice the distance, 120 kilometers, you'll need 8 liters of fuel. The ratio of fuel consumed to distance covered remains consistent.
Okay, I'm starting to see the pattern here. But how do we actually solve problems involving direct proportion? Is there a magic formula?
Well, the textbook provides a handy formula, but we can think about it intuitively, too. If we know the relationship between two quantities, like the fuel consumption example we just talked about, we can use that ratio to calculate for different values.
Right. This reminds me of something I found really cool in the textbook, the example about a clock. It might sound simple, but think about it. As time passes, the minute hand on a clock moves, right?
Absolutely. The distance the minute hand travels is directly proportional to the time that has passed. If it moves a certain distance in 5 minutes, it'll move double that distance in 10 minutes.
So direct proportion is all about things increasing or decreasing together at a steady pace. But I have a feeling it can't be applied to everything.
You're right. That's an important point to remember. Not everything in life follows this neat, direct relationship. Take human growth, for example. Kids don't just keep getting taller at a constant rate until they're adults.
That's a relief. I was starting to get a bit concerned there.
Even something like the relationship between a tree's height and its leaf count doesn't fit neatly into a direct proportion. There are way too many other factors involved.
So direct proportion has its limits. But that just makes things more interesting, right? Because it means there are other types of proportions at play in the world. Speaking of other types of proportions, let's talk about what happens when one thing going up means another goes down. That's where inverse proportion comes in. Like, imagine you're making pizzas and you've got a set amount of dough. The more people you want to feed, the smaller each slice has to be, right?
Right. That's a great analogy. And the textbook uses a similar example, right? If you have a fixed budget for buying textbooks and the price per book goes up, you can buy fewer books. One goes up, the other goes down. That's inverse proportion in a nutshell.
It's like a constant trade-off. The textbook also mentions someone named Zahida and her different methods of getting to school. Walking, running, cycling, and driving. I bet that ties into this too.
Absolutely. Let's say it takes Zahida an hour to walk to school. If she cycles 3 times faster, it'll only take her 20 minutes. The faster she goes, the less time she spends traveling.
That makes perfect sense. It's like when I'm running late and I decide to take a taxi instead of the bus.
Right.
I'm paying more, but I'm cutting down on travel time.
Exactly. It's all about understanding the relationship between these quantities. In inverse proportion, as one quantity increases, the other decreases, but their product remains constant.
Okay, that's really interesting. But I'm a visual learner. Is there a way to see inverse proportion in action? Like a diagram or something?
No, the textbook actually has this neat activity with counters on a grid. You start with a certain number of counters and arrange them in different rows. When you increase the number of rows, the number of counters in each row decreases.
That's a really cool way to visualize it. I might have to try that myself later. So we've covered 2 key types of proportions today, direct and inverse. In direct proportion, both quantities move in the same direction, while in inverse proportion, they move in opposite directions.
Yeah, and what's important to remember is that both direct and inverse proportions are everywhere around us. Think about map scales. They use direct proportion to represent real-world distances on a smaller piece of paper. Or think about work efficiency. Often, the more people working on a task, the faster it gets done, which is an example of inverse proportion.
Wow, I never realized how relevant these mathematical concepts are to everyday life. I feel like I'm looking at the world with a whole new perspective now. So here's a final thought for you to chew on. As you go about your day, see if you can spot examples of direct or inverse proportions in action. You might be surprised by how many you find. That's a wrap for our deep dive into the world of proportions. Join us next time when we'll unpack another fascinating topic. You never know what we might uncover.